Welcome to our webinar today. My name is Nico Kabar. I'm a solution architect at Tayera, and today we will be talking about Calico and Kubernetes Network Policies, kind of going through their definition, how to compare and contrast, when to use when, and some examples along the way. If this is your first webinar with us, know that this will be recorded. So you can go back at any time. We'll post the videos on YouTube, on the Tayera channel, as well as on the events page. So you can always go back and rewatch it. Feel free throughout this discussion to raise any questions. There's a Q&A area that I'm happy to kind of go through. I can't see it right now because I'm in presenting mode, but happy to go through and answer your questions towards the end of the discussion. So let's get started. Again, a quick note about myself. I'm a solution architect at Tayera. Previously was at Docker and Cisco prior to that. So pretty much my whole tenure within IT has been around containers, Kubernetes, networking, and cloud. Feel free to reach out. This is my email if there's anything that goes unanswered here, or if there's anything that you would like to discuss, happy to, if you reach out directly to me, this is my email on the screen. So before we begin, for those of you who are not familiar with Project Calico, so Project Calico started around the same time Kubernetes did. It's a community-driven, open source project focused on delivering solutions for, Kubernetes networking and network security for Kubernetes, as well as actually went beyond that for other applications running on virtual machines and host-based workloads. So, at a glance, why many users out there use Project Calico? It is blazing fast in terms of providing connectivity and networking and the plumbing basically around pod-to-pod networking, because we use native Linux data plane to perform all the connectivity between pods running in your Kubernetes. We're known to provide the layer 3 network. Of course, there's other options to use encapsulation such as VXLAN and IPNFP, but many of our users today are using Calico without encapsulation, providing really high performance, low latency, and simple architecturally networks for Kubernetes. It is massively scalable because it's built on BGP, which is kind of the internet's routing protocol. So it scales really to the limit of Kubernetes itself. The industry players, like cloud players, as well as other platform players, given the cloud, AWS, Google, Azure, IBM, have standardized on using Calico, at least for network policies. It's also been embedded with Docker Enterprise from Kubernetes, as well as Rancher as an option for Calico, as well as kind of deep integration as a supported option for Red Hat OpenShift. So regardless of what platform or Kubernetes solution that you use, whether it is on-prem or cloud-based, managed or not, Calico is an option for you, and it's been used with various platforms across the globe. Of course, we are, we're proven with real-world production workloads today. It's been trusted and running in production at large enterprises, financial services, SaaS, medical, healthcare, you name it. And we're aware of more than 150,000 known clusters out there that are using Calico today, with thousands and thousands of nodes. Now, let's talk about Tayera, which is a company behind Calico. So we're the leader in Kubernetes network security. We are inventors and maintainers of Project Calico, and we also help co-lead some of the earlier SEO security working groups. And we, some of our engineers today and product were highly or kind of tightly integrated with some of the upstream projects, as well as the SIGs, network SIG in Kubernetes as well. So in terms of the Calico Enterprise solution, which is the enterprise solution that we offer on top of Project Calico, that goes beyond what Project Calico provides out of the box in open source. The main focus of Calico Enterprise is around some of the more advanced enterprise functionalities needed to really support enterprise workloads. And as you can see, we have numerous of kind of top Fortune 100, Fortune 500 customers that are trusting us with running their workloads using Calico Enterprise today. As I mentioned earlier, Calico itself and Calico Enterprise can run on wherever your Kubernetes runs. So if you're talking about any of the managed Kubernetes services like EKS, GKE, AKS, IKS, or you're talking about upstream Kubernetes or some of the managed on-prem Kubernetes, also things like Anthos and all the on-prem managed services, as well as VMware Tanzu, which also picked Calico to be the standard for their CNI. Now, as I mentioned earlier, that beyond Kubernetes, Calico had been used by some of our largest customers today to not only secure their Kubernetes networks or Kubernetes workloads, but also run it natively on VMs and bare metal. So that's a capability that allows you to use the same approach when defining segments or segmentation using network policies, or certain network policy features also in Calico Enterprise to actually run it and to secure workloads running on VMs and bare metal. So keep that in mind, as Calico can provide that kind of common layer that can run basically and secure your Kubernetes and non-Kubernetes workloads. So let's switch over to why a network policy. Some of you have maybe played with network policies. Kubernetes network policies. I've been speaking with a lot of customers who are familiar with the concept, understand why they're important, but also hesitant to use them because of certain factors around, not sure if they're the right solution, or they're not sure that they're gonna mess something up for other namespaces and so forth. So let's kind of dig deeper on why many users out there need network policies and how they can help you. So by definition, the Kubernetes network model is a flat network. Regardless of the CNI that you use, out of the box, Kubernetes design expects the CNI to provide a unnetted, clean TCP/IP network for pods. So pods can communicate with each other without any NATs across the cluster. Now, the second point is, there's a dynamic schedule of pods, kind of creates, results in, the IPs being dynamic, they're non-static, they're ephemeral, and pods can be located, dynamically across different nodes. That's kind of the normal situation. Of course, you can use certain approaches to ensure that they're running in certain nodes, but traditionally they're running dynamically, and they've been assigned IPs dynamically. And in many cases, not always, in many cases, those IPs for pods are non-writable within your environment. That means they're only locally significant to the cluster. So therefore, the firewalls in between, if you have any perimeter firewall capability, the IP addresses of the pods are not gonna make a lot of sense, let alone that most likely it's gonna be netted out of the cluster. So there's no deterministic way to pinpoint the pod network and traffic based on specific IPs. So those all kind of lead us to the reason why we need network policies and Kubernetes network policies, because using traditional firewalling to secure your application is not going to really work because of those reasons. So in the new world of kind of Kubernetes and cloud native workloads, there needs to be a better way to secure applications that uses more cloud native primitives, one being labels and selectors. So instead of using IP addresses, which as I mentioned, they're dynamic and non-deterministic, labels are a much better approach to group pods or applications or resources and use that to apply policies. Second, any network policies needs to be declarative in nature. That meaning you define what's the end state of how your application security posture should look like, what you want to permit, how different components need to talk to each other, and you leave it up to Kubernetes API to translate that and Calico to enforce that. So as you scale your application, as you add more applications, remove applications, workloads, pods, whatever it is, you don't have to redefine your policies. Finally, a hard requirement is that this needs to be dynamic, right? We are not in the era of static, per IP definition of policies, where there's manual intervention that kind of causes lots of delays in actually executing things, can apply those policies, and two, the human error that can actually take down workloads and cause outages. So those are three key kind of pillars around why Kubernetes network policies and how Calico also enforces them are defined by those key attributes. So how we compare this to a traditional approach, I'm not going to go through this long list, but traditionally with firewall-based zoning, you create your zones. Most likely it's based on VMs or VM-based racks or zones within your data center or VPC. But three key areas that I wanted to kind of highlight in this kind of cloud native approach. One is where do you enforce the actual policies? Typically, and traditionally, it's been enforced sometimes at the network layer. That means that if traffic has been supposed to be blocked, it actually traverses all the way to the network level, or maybe to the bottleneck being the firewall before it actually gets denied. With Calico and how it enforces network policies, they're being enforced as close as possible to the pod, actually at the leaf of the pod itself. Therefore, if the traffic is not intended to, it's not permitted, it's going to be blocked right there without adding more traffic to your network pipes. The second one is around how you dynamically calculate policies. Again, it's not based on IPs or IP ranges. With the cloud native approach with Kubernetes Network Policies, you're actually defining them based on labels, and so it's a lot more human readable and dynamic nature. And you let Calico kind of translate labels to IPs when it actually enforces them based on IP at the end of the day, using either IP tables or eBPF or other OS capabilities and firewalling. But the translation is being done not by a human being here; it's being done by Kubernetes API as well as Calico. And finally, around the speed at which we're enforcing changes, it's since this is a distributed model where Calico runs on every node in the cluster, and it listens to changes to the policy, if any. It's able to dynamically apply those changes in a matter of milliseconds across all the cluster nodes where those policies are being enforced. So those are the kind of key things to remember when comparing the new cloud native approach to network policies to the traditional approach. So let's define Kubernetes network policies. Maybe this could be repetitive for some of you, but at the high level, kind of lets admins or even application developers define the network rules used, that define their application using the same Kubernetes deployment artifacts, YAML-based artifacts that define not only just the application definition, but also the network security definition for the application. It is supported natively with the Network Policy Kubernetes API, so entry within Kubernetes. However, Kubernetes itself does not enforce any policies. It relies on the CNI to enforce the policies. Calico being a leader in this area, but there are, of course, other CNIs out there that can do that. Policies are namespace scoped similar to a lot of resources in Kubernetes, so you need to define policies for a specific namespace for a specific use case. And policies are applied to pods using labels and selectors, as we mentioned. So you use labels to label the pods or deployments, and then you use selectors to apply the policies to to a subset or to the whole set of a pod or pods in your application. Policies can specify traffic to and from namespaces, pods, or IP siders. So this is when you're trying to define, or limit or allow the traffic to or from your application. And you can select, the source of the traffic or the destination of the traffic being namespace, the pod itself using the labels, or the actual IP siders. Of course, so the definition of network policies can be, you can use kubectl to, apply them and work with them as well. They can also be used, I mentioned this, any other CNI can be can enforce those policies. The CNI is required to enforce a policy. They work across TCP and UDP, and you can select port or port ranges. Actually, I think port range is only available with Calico Network Policies, but we'll get to that in a minute. Policies can define rules in either the ingress, so things coming into the pod. So if you're looking at the pod, think about like this little firewall right in front of the pod. Ingress is coming into the pod, and egress is leaving the pod. So this is really important to note, is that by default, right, if no policies apply to pod, all the traffic is allowed to and from the pod. So if you launch a new Kubernetes cluster today, by default, every pod can talk to any other pod across any namespace, right? Without, there's no policies applied to it. So it is by design, that is the case. Now, the moment that you apply a policy that applies to a pod, you're basically triggering a default implicit deny, right? That means that the moment that you apply a policy, there is a implicit deny. Therefore, you have to, with Kubernetes Network Policy, you actually have to specify a rule in the policy to allow certain traffic. And that's kind of it's really kind of important to understand that behavior. So there's an implicit deny the moment that you apply any policy to a pod. So let's take some examples here. Very simple example where we have a namespace called MySpace. And we have 3 types of pods: front end, helper, and DB. And in this example that we're showing the YAML for on the left-hand side, what we're trying to do is ensure that for the DB pods, they can only accept traffic, TCP traffic on coming from the front-end pods and connecting to port 6379. So if we take a look at the left-hand side, a couple things to note. The API version is networking.kubernetes.io. That means it's a Kubernetes network policy. We'll see how the Calico network policy is going to look like from the API version in the following examples. The kind is a network policy. As you can see here, it's namespace scoped to my namespace. Where we're applying the policy is where we use a pod selector, where we're matching the label of role equals DB. So all the pods with that label. Again, we did not, as we scale up or down the pods, it's going to automatically enforce that. And we're enforcing traffic, or we're allowing traffic. Remember, the moment that we, in Kubernetes network policies, we're only specifying what's allowed in the policy because there will be an implicit deny. So we're only allowing traffic coming from the front-end pods and connecting to TCP port 6379. That means that the moment that we apply this, it's going to be only applied on those pods in blue, the DB pods. And by notion of it, if this pod tries to connect to DB, it will be blocked because it's not specified as part of an allowed rule in any policy that is applied to the database pods. So this is one example, straightforward there. Another example where we're using a set of labels, right? There could be a use case to allow traffic to specific sites. This is the case if you're trying to do, egress traffic leading to a non-Kubernetes resource where you can use labels. We'll talk more about some other ways you can do this, but one way is to use actual CIDR blocks. So in this case, if I wanted the color red pods in the default namespace to be able to talk to the 172.118.0.24 subnet, whether that belongs to the same Kubernetes cluster or it belongs to some external cluster, doesn't really matter. As long as the destination IP belongs to this subnet, it will be allowed. If this pod tries to connect to any other, IP that does not belong in this policy, it will be blocked. So this is another example here where we're using CIDRs instead of pod labels. Another example here is the default deny, which we definitely recommend. As I mentioned, everything by default is going to be allowed, but then recommend to use the default deny. Therefore, you're going to be denying all the traffic and then opening it up as needed. So in this case, we're applying it to all the open brackets is for all the pods and this my namespace and we're specifying that it's going to be in both the ingress and egress direction. And since we're not giving any rules to where, that means it's going to be, everything's going to be blocked. So this is a good pattern, best practices to, when you create namespaces, to start there and then open things up as needed. So let's switch over to Calico Network Policies. So just to kind of highlight, there is a difference between Kubernetes Network Policies and Calico Network Policies. Both are open source. With Kubernetes Network Policies, you can use other CNIs to enforce it, Calico being one. With Calico Network Policy, it's open source, but of course you have to use Calico because it's a different kind of CRD that is used. And we'll talk more around what are the value-added features in Calico Network Policy. So in a nutshell, it extends Kubernetes Network Policies. So it's a superset that includes everything that Kubernetes Network Policies do, but add a bit more to that. So one, of course, it requires Calico Network Policies to be applied. Two, it can be applied via kubectl or Calico Ctl, which is another CLI to use when that we provide. It's an easy to use CLI tool to interact with the cluster and all things networking and policy around it. It supports policy ordering and precedence, so you can actually specify the order in which the policy rules are being enforced. If you come from a firewall admin or ACL definition history, and you've done that, this can be critical in how you define your policies. We support also layer 3 to layer 7 match rules when combined with Istio and Envoy. So we have the capability to interact with, if you're running Istio and Envoy, to define a policy YAML all in one place. And then, the layer 3, layer 4 rules will be enforced by Calico. And then you can define layer 7 rules like HTTP, verbs and actions to be allowed or denied that will be enforced by Envoy. But the value here is that you have it all in single policy, and it can be applied, from layer 3 all the way to layer 7. We can also protect VMs and host interfaces, not just pods. So with Kubernetes Network Policies, you're kind of limited to pods, but with Calico Network Policies, you can actually, as I mentioned, run Calico as a service on an EC2 instance or a VM or a bare metal instance, and then define a policy that in one place you can allow traffic coming or going through the native services running on Linux, and have them also be enforced as well as on the pods as well. Supports for both namespace as well global scoped. So we also have a global scoped policies that can be applied selectively to certain namespaces or across all namespaces. So you don't have to repeat yourself by creating a policy and have it be applied to every namespace. Supports additional actions. So as I mentioned earlier, with Kubernetes network policies, there are technically no actions in the rule definition, because there's an implicit deny and you're only allowed to basically specify what's being allowed. In Calico, you actually have two major actions. You can allow or deny the traffic, but also you can supplement that with logging what you denied or allowed, or passing, so that you don't have to evaluate other rules and so forth. So it's a bit more dynamic in terms of what it allows you to do within the policy. 1 second. I'm seeing there's some questions. I can't see them right now, but happy to answer them. We'll leave some time towards the end to answer them. So feel free, if you have any questions, to plug them in the Q&A section, and I'll answer them towards the end. The last but not least, which is kind of a very critical point that a lot of users kind of are most likely unaware of, but unlike pods, service accounts and namespaces labels are RBAC. That means that typically, if you give, from an RBAC perspective, you give users the ability to create pods. That means that they have the ability to also alter, change, or add labels to their pods. Therefore, if we're using purely pod labels to group pods or allow them based on a Kubernetes network policy, there is a risk there that by someone kind of mislabeling or changing the label, that they can escape from that policy. So one approach to address that is using service account labels. So typically, service accounts are not created by the actual service account users or the bots or whoever are using the service accounts themselves. Usually they're created previously similar to namespaces. So by using service accounts labels, you can actually use them in the policy, but ensure that way that there's no way that the labels can be altered, because traditionally and for the most part, the service account owners do not have the ability to alter labels on those service accounts. Finally, everything I'm kind of talked about and mentioned here is available for you in open source. So if you're using any managed Kubernetes cluster like GKE, EKS, AKS, and you enabled the policy enforcement, so by that nature, you enabled Calico because they use Calico for network policies, you're able to use all the stuff that I talked about. So if you're using Calico on-prem, you're also able to do this as well. Now, we use Calico Network Policy also as a foundation for some of the enterprise advanced capabilities. I'm going to mention a few here. We have something called DNS policies, where if you're trying to limit access or allow access, for that matter, to certain services outside the cluster, or you want to use a domain name instead of CIDRs or IPs, because those are not dynamic, you can do so with Calico Enterprise. We have also certain capabilities on how you can manage those policies with tiering, previewing the policies, ensuring that before you apply the policy, you understand the impact of the policy, staging, policy recommendations. So we have a long list of features and functionalities for in Calico Enterprise that are based on Calico Network Policies. So let's take a few examples here for Calico Network Policies. So the example number one is a global policy. So as I mentioned, Calico Network Policies you can use it. They can be global, so the kind will be global network policy. One thing you notice here that the API version is project.calico.org, and it's not networking.kubernetes.io, because the moment you install Calico, you'll be able to use those extended resources here. And you can see here that in this example, we're basically trying to, instead of working at the pod labels on the pod level, we're allowing or denying traffic based on the namespace and using the namespace selector. So this can be a useful method for looking at things from a global perspective across namespaces. And you can manage them using, kubectl as well. So you can see here that you can manage global network policies that become just another resource within Kubernetes. And you can manage them using kubectl. Another kind of more advanced policy here is what a couple of things that we're trying to do here. One is showcasing that there is an ordering capability within Calico Network Policies. We're specifying that we want to explicitly deny the traffic coming from this specific service account. So any application, any pod that has a service account associated with it that is a SRE account will be denied to connect on TCP to this helper pod, right? So just a random example here. So we showcase that you can have an order, right? The smaller the order is, the area it's going to be enforced or evaluated. So order 900 here is going to be evaluated before order 1000. We're going to explicitly deny any traffic coming from this specific service account. And then also we're going to log. So we're not going to take any action. We're not going to take any action for the traffic coming from the namespace green into the helper role pod within my namespace, but we're going to log it. So you're going to be able to see it in the wherever the CNI logs. So usually it's with kubelet logs will be there as well. So you'll see every time there's a connection, ICMP connection coming from anywhere in this namespace to the specific pod. So this is more advanced. You can see like there's more advanced capabilities that can do. It's a very granular, with the amount of features that you have, you can be very, very specific on what you can do and get the logs for some of the actions that the policy enforcement does for you there. Another example here that this is more focused on Calico Enterprise policy capabilities. What you see here on the right-hand side is a kind of a snippet from the UI where we show tiers. So each of those columns is a tier. So there's a security, platform, and default tiers. Each of those entries here is a policy. So you can have it's kind of easier to visualize those policies, make changes here, and have them in tiers, which is basically going to make sure that higher tiers that are coming in this example, the security will be enforced before lower tier, like the default tier, will be enforced. We're not talking about namespaces here. We're talking about network policy tiers. You can see also here that there's some staged policies. So there's a way you can actually stage some policies, preview them. So more granular workflows around operationalizing network policies. Other things that I wanted to highlight here is the DNS policies. So in this example, we have the Twilio integration policy that the platform team had created. Everything that you see here, you can download it in YAML. So the YAML definition for this specific Twilio integration policy is, first of all, it's a global network policy. It's part of the platform tier. It has a very high order. That means it's going to be evaluated, early on, and it's going to be allowing all the namespaces with the Twilio equals allowed label to be able to any pod running in that namespace to be able to talk to this wildcard subdomain of Twilio.com. Therefore, any pod can communicate clearly to or freely to the Twilio APIs or so forth. And we're going to deny everything else. So this is another simple example of using DNS policies in a global network policy that's being applied in the egress direction there. So another key capability with Calico Network Policy, specifically with Calico Enterprise. So some of the key takeaways, so we can leave some room for questions. Kubernetes network policies enable kind of applications to declare segmentation controls to restrict access to authorized workloads. So this is your new, new segments, new You know, and especially in a zero trust model, you wanna, there's no like, you know, there's no physical segmentation here. We're talking about clearly stating what is your application network security zoning needs to look like, regardless of how it runs, where it runs, and defining policies around that using Kubernetes Network Policies. Calico Network Policies, on the other hand, are more sophisticated superset of Kubernetes Network Policies that include a number of advanced policies features, and you know, and we've seen them in the real world examples, as well as in Calico Enterprise with even more advanced capabilities and management of policies. And Calico provides kind of scalable implementation of network policies and proven very large-scale production deployments, yet simple to use and operate. We've seen how simple it is kind of to understand that YAML definition of the policy. There's plenty of examples as well that I'll talk about here. So in terms of additional resources, if you head to docs.projectcalico.org, there's plenty of really thorough examples of different use cases and some examples for the policy definition that can help you as you're learning more on policies. So keep an eye for that resource, as well as this is another cool GitHub repo. I'll plug it into chat in a minute, but it talks about, you know, there's probably maybe 50 plus, 60 plus examples of what you can do with some visualization that this, I think his name is Ahmed, he's a network engineer or a software engineer at Google who put this together. So it's a good resource to kind of look into, and as you're learning more about network policies, a great resource for you there. Similar to this events, we have a couple of upcoming events, you know, as you can see here. So keep an eye for, you know, under Tayera events, or if you haven't signed up, there's a mailer you can sign up so you can get notified when we add new events. There's plenty of events coming up, and you know, covering a wide range of topics. So feel free to kind of sign up to those as well. And finally, if you've never tried Calico Enterprise, feel free to go to Tayera trial. We provision a cluster for you, and you can actually run through some examples and get to understand how to create policies, how to troubleshoot certain network issues, and it's a cool kind of multi-lab environment that you can have for free. So feel free to sign up at Tayera trial, and we'll be providing you with all that's needed to get started with Calico Enterprise for you to kind of learn more. So that's it in terms of the content here. Hopefully this was helpful. I'm going to stop sharing right now my screen and answer some questions in the Q&A. Again, thank you so much for joining us. And again, the recording will be available for you in Tayera events site, as well as on YouTube. So let me switch over to the question to see if I can answer any.